Hi, everybody. So if you're watching this video, you are ready to do the properties of reflections. All right, so this is the last math that you actually have to prove, okay? So let's get started. That means you have finished this piece right here. So your table is complete. You have done a translation, a dilation, a reflection, and a rotation. You have ensured that it is a composition of those transformations. You have submitted your spreadsheet for the last time, okay? Ms. Lawrence now has your completed spreadsheet. And so now you're ready to do the math. And this is the last math that you're gonna have to turn in for the 4 transformations that you have done and shown the properties and proven the properties for. So let's talk about the 2 things that we're gonna prove for reflection, okay? So here we go. Goal 1, you're gonna prove the lines from the pre-image points to their corresponding image points are perpendicular to the line of reflection. Whoa, that word perpendicular. That means you're going to find the slope of the lines. And if the slopes are perpendicular, meaning they are the negative reciprocals of each other, then the lines are perpendicular. Okay, so that's what we're going to prove. Goal 2, we're going to prove the points on the line of reflection is the midpoint of the pre-image point and its corresponding image point. So there's going to be a line segment from the pre-image to the image point. And we're going to prove that the line of reflection, the midpoint of that line, is on the line of reflection. So we're going to prove that the line of reflection is in the middle. The video that we're creating is going to go right here. Okay, so let's look at step 1. You're going to pick a point on your new domain. You're going to identify the corresponding point on the image. The line segment that contains a point from your pre-image and the corresponding image is going to create a line, right? And so you're going to capture your 2 points. And this is what you're going to do. You're going to find the slope of that line, and you're going to find the midpoint of that line. So you just go ahead and do 2 things at the same time, okay? Find the slope and the midpoint of that line. You're going to find the slope of the line of reflection. And you're going to take these 2 lines and you're going to compare the slopes. Remember, if the slopes are perpendicular, then we have proven that the line segment is perpendicular to the line of reflection, which is one of the properties that you need to prove. So remember when you found the midpoint here? When you find the midpoint, you're going to prove that the midpoint is on the line of reflection. Okay, and once you have done that, congratulations. You are done with step 2 and part C through F of step 5, like you did 2 different steps at the same time. I told you Ms. Lawrence was going to hook you up and I was going to walk you through it. I told you. All right, so let's get started. What point will we use? Well, as I've done in the previous videos, I've used E and F, and I'm just going to continue to go with either one of those. So I'm actually just going to continue to use E here. So that means that my pre-image point is going to be 2, negative 0.4167, and my image point is going to be 0.416 and negative 2. And so those are the 2 points that I'm going to use to do the math. Okay, so once again, this is my pre-image and this will be my image. As we've done in the past, let's go ahead and take a picture of these points so we don't have to keep toggling back and forth, making sure we wrote it down correctly. Okay, so here I'm going to give you a visual of what we're going to prove for reflection. Okay, So let's go ahead and turn off all the other ones that we don't need. We don't need the pre-image, right? The original. We don't need translation or dilation because that was not our pre-image for reflection. Okay, so what we need is the rotation and the reflection because those were the last two we did. The rotation is the pre-image for our reflection. So that's what we need. So let's start here. This was my line of reflection. So this point should be a point on the line of reflection. So let's talk about what the points on the line of reflection look like. Let's make a little table for those points, okay? So you can see the pattern of those points. So let's start with -3. If I plug -3 in here, right? So that means, and remember this is already negative. So a negative, -3 makes a +3. So that means, and remember this is already negative. So a negative, -3 makes a +3. Let's do -2. A negative, -2 makes a +2. All right, let's do -1. A negative, -1 makes a +1. Let's do 0. 0 is neither positive nor negative, so it's going to come out to be 0. Let's do a +1. A +1 and a negative makes a -1. Plug in 2. 2, a +2 and a -1 makes a -2. Let's plug in 3. A +3 and a negative makes it a -3. So now that you know the pattern of the table, you'll be able to recognize whether this point actually would fall on this table in between these numbers. Okay, so let's get a visual of what we are trying to prove for reflection. So remember, there are two things that we're trying to prove for reflection. All right, so let's go ahead and identify the points that we were using for here. So A, B, C, D, E, that means this is the point that I was using. All right, so let's identify that point on our picture. So 2, 0 point right here, okay, -0.4167. And the corresponding point for that one is going to be on the curve here, right here. Okay, so we got our 2 points. All right, and let's get like a bright color so we can see this. So we said this line segment, that line segment, what we wanted to do was find the slope of that line, and we also wanted to find the midpoint of that line. Okay. Now, where's the line of reflection? Let's talk about that, and let's get another color for that. So the line of reflection, I'm going to make it like a pink color. My line of reflection was y equals -x, which meant my slope was negative, right? So this is the line y equals -x. These are the points on a line y equals -x. These are the points on the line of y equals -x. Okay, and I know that from the table that we created when we did our work. So remember, the slope is -1, so you start at the center, and the y-intercept was 0. So y equals -x, right? If we look at it in y equals mx plus b form, the b here, remember there's no b here, so that b is 0, so that's why we start at 0. We start here. And the slope was -1. Slope was -1, right? Right there, the slope is -1. So we go up 1 to the left 1, up 1 to the left 1, in a negative direction, up 1 to the left 1. And that gets our point. Okay, so That is what we're trying to look at. So we are saying, hey, if we take the slope of this line, all right, the slope of the purple line here, is this line perpendicular to the pink line? Is it perpendicular? That's what we're checking. So are the lines perpendicular? Meaning are they negative reciprocals? Okay, they kind of look like they are, but we got to prove it. Question mark, question mark. The other thing that you had to do was the midpoint, right? Go to was the midpoint. So we had to prove that this point was on this line. And as you can see, it is, right? This point is actually in between these 2 points on the line. Okay, so we had to prove that. So those are the 2 things that you need to prove for the reflection, line of reflection, the properties of the line of reflection. I'm going to make this midpoint green so you can see what I'm talking about. It's on that line. We just wanted to prove that it's on that line. That's it. Just prove. As we mentioned before, remember we're doing E and E prime. So my pre-image point is 2, negative 0.4167. And E prime would be 0.4167, comma, negative 2. Okay. So remember, our first goal is to find the midpoint of that line. We're going to find the midpoint of that line. So remember, this is the pre-image. This is the line segment that we talked about from the pre-image to the image. So we're going to find the midpoint of that line. And we're also going to find the slope of that line. Okay, so let's do it. So midpoint formula is x1 plus x2 over 2. So you're taking the average of the x coordinates, and y1 plus y2 over 2, which means you're taking the average of the y coordinates. So the average of the x coordinates, average of the y coordinates. So I'm just going to label this x1, y1, x2, y2. And so we're going to say 2 plus 0.4167 and divide that by 2. And we're going to say negative 0.4167 plus negative 2, divide that by 2. Okay? And you are going to work that math out, okay? But here's what we know. This point is on the line of reflection. This point should be on the line of reflection. And what's my line of reflection again? My line of reflection. Now, let's check the slope, which was the second goal, right? We want to check to see if the lines are perpendicular. So we're going to find the slope of this line, and we're going to compare it to the slope of the line of reflection. So the slope of this line, remember slope formula is y2 minus y1 over x2 minus x1. All right, so let's do it. Y2 is negative 2 minus a negative 0.4167 over 0.4167 minus 2. And we're going to get that slope, okay? And we're going to compare it to the slope of y equals negative x. Well, you should remember from Math 1 that the slope, right, is y equals, in the equation y equals mx plus b is always m. And so if we line these up, right? Line these up, okay? We notice that there's no b, or the b is 0, and that our slope is actually a -1. So the slope of my line is -1. The slope of my line is -1. So I want to check to make sure that this slope is perpendicular to this slope. This slope is perpendicular to this slope. If they are perpendicular, then I have proven that the lines are perpendicular. Let's look at the slope of the other lines up here. So the slope of x equals negative, it's going to be the slope of the x-axis is a horizontal line. Excuse me, it's a horizontal line, yes. It's a horizontal line. Let me get that word spelled correctly. And that line is y equals 0. In that case, the slope is 0. Okay? In this case, this is a vertical line. The r reflection over the y-axis. This will be a vertical line. The equation is x equals 0. And the slope would be undefined. The slope would be undefined. In this case, y equals x. It's kind of like my line, right? Remember we just talked about y equals mx, right? So that means the number in front of the x would be a 1. So in this case, the slope would be 1 for this line. Okay. So here's one last thing I'm going to tell you that might help you. Whenever you have two lines, okay, one being slope is 0 and one being the slope is undefined, those lines are going to be perpendicular. Okay, so if one of your slopes come out to be 0 and the other one comes out to be undefined, those two lines are perpendicular. You should have learned that in Math 1, but we review it here in Math 2. And that's how you do the math